Mr. Peters was playing Mrs. Peters in horse. Over the last summer, they would play randomly, and Mrs. Peters won 35 out of 60 games. It is assumed that the games being played are independent of each other. Create a 95% confidence interval for the long-term percentage of games that Mr. Peters would win. Show all the panic steps for full credit. All right, so panic steps. Step number one. All right, parameter of interest. We are going to try to find the true proportion of games that Mr. Peters wins. All right. A, assumptions and conditions. Okay. So random, that's stated in the question. Each game is independent of other games. That is stated in the question as well. And then finally, for normality, we need to check that NP and NQ are both greater than 10. All right, so NP is we had 60 games. I won 25 out of 60 of them. All right, that equals 25. And then NQ, Q is just 1 minus P, is 35 out of 60. That's a really ugly 6. And that's going to be 35 as well. All right. So check the distribution is approximately normal. All right. N, we're going to name the test. This is going to be a 1 prop Z interval. Okay, PAN. All right, now we're going to actually compute. All right, so I'm going to show the general formula. So the general formula is P hat plus or minus the Z score. The standard deviation is P1 minus P over N. All right, P hat, that's going to be our 25 out of 60. Okay, so just really fast, 25 out of 60. Is, for the sake of simple numbers, let's just call that 0.42. All right, Z-score, I need my critical value. So we have a 95% confidence interval. Remember, if you have a 95% confidence interval, so that means you have 95% in the middle. That means you have tails of 2.5%. All right, or 0.025. So I need to hunt through here to find 0.025, which happens to be right here. If I line it up, it goes with 1.96. So 1.96 is going to be my critical value. For P, we don't have a population value. We just have a sample value. So we're just going to reuse P hat. And our sample size is 60. Okay, to crunch these numbers, first off, it's really easy to make a mistake when punching this into the calculator. So we're going to use a little calculator shortcut. All right, if you go under stat, go over to tests, there is a 1 prop Z interval. There it is. Then this little menu pops up right here. X, this is the number of successes. Don't put P hat in here. So in this case, we're calculating Mr. Peters winning 25 games. All right. Our N is our sample size at a 60. And then for our confidence level, it's 95%. Calculate that, and we get roughly 0.29 to 0.54. Now we have to interpret this, make a conclusion. So I am 95% confident that the true proportion of horse games won by Mr. Peters is between 0.29 and 0.54. Okay, so there you go. That's your part A. That's the full-blown confidence interval. Given your interval, is there evidence that Mr. Peter or that Mrs. Peters is better than Mr. Peters? So 50% indicates that we are equally skilled. All right. Since 50% is in the interval, it is a plausible value. All right. So because us being evenly skilled is possible, and shoot, the interval even goes above 50% up to 54. So it is plausible that I actually could be better than her. Okay. But what we're going to say is that since the entire interval is not below 50%, the entire interval being below 50% would indicate that she is better than me, that there is no way that I win at least half or more of the games. So since the entire interval is below, oh my God, is not below. Good job by me. We cannot say with 95% confidence, you always want to drop that interval or the confidence level somewhere. We cannot say with 95% confidence that Mrs. Peters is better. All right, so there you go.